In this lesson, we're not going to be looking at quadratic equations, but quadratic inequalities. So, we're going to look at equations hopefully in standard form. If they're not, we're going to get them in standard form that looks like this, but instead of having an equal sign, it's going to be replaced with an inequality sign that of course is greater than, less than, greater than or equal to, less than or equal to. I'm going to do it in a little bit probably unconventional way where we're going to use the graph to determine the answer. I think it's a lot easier than using test points. However, if you like that method and you've learned it from a different teacher or instructor, go for it. So, this is my process. We're going to write the given inequality in standard form. We're going to solve it by factoring or the quadratic formula, hopefully mostly by factoring. We're going to plot our answers on a number line, and then we're going to use the graph of the parabola to solve the inequality. And then we're going to write our answers in interval notation. So on example number 1, it's not in standard form, so do I need to multiply that out? Not really, because let's just look at step 2. It says we need to solve it, and one method of solving is factoring. Well, it's already factored for us, so let's take advantage of that. Now, read number 2 carefully. It says solve the corresponding equation. So really, we're going to look at this as an equal sign. We're going to take this inequality at the very last step. So we're going to solve it as an equation. So when I solve by factoring, I set each factor equal to 0 and solve for x. Step 3 says plot those numbers on a number line. Now we're going to look at the inequality. So let's come back up here. So that's just a greater than. Since it's not equal to, that means those need to be open circles because these values would make this equal to 0. So I don't want to be equal, I want to get as close to as possible. Now, how do I know when it's greater than? Well, go back to your parabola where you have f of x is equal to this. And if I were to FOIL that out, that would be a parabola. Let's just go ahead and do that. That would be x squared minus 4x minus 5. And would we all agree that a is 1? If a is 1, that means the parabola goes up. It looks like that somehow. Well, if it goes up and it has to cross, this is the x-axis. And it would have to cross the x-axis at -1 and 5. Wouldn't that parabola have to look something like this? We don't care where the vertex is. We just know it looks something like that. And you're going, where are you going with this, Ms. Turnell? Hold on. I'm asking you to find where is this parabola greater than 0? Greater than 0. That means above the x-axis. Where is this graph above the x-axis? Well, here and here. Well, what is the domain for that part? What are the x values? Well, those values correspond where this is going up in that part here and here, right? That's all of this. So how do we write that? So it means when x is going bigger, y is up. When x is going left of -1, y is up. It's above the x-axis. So what is the domain? Left to right. That's from -infinity to -1 with a parenthesis because of the open circle, union 5 to infinity. So if you can tell above or below, you're going to get this. It's really easy. Let's look at number 2. So it's not factored. So again, we're going to take the corresponding equation. I'm going to solve that by factoring. So let's see, I think I need a 5 here and the 1 here. I'm going to check my signs. That looks good. I set each factor equal to 0. and solve for x. Again, the corresponding equation. So I put those numbers on a number line. Now be careful, they have to be in the right order. So -1 goes here, 5/2 comes over here somewhere. Now we're going to worry about the inequality. This time it does have an equal to part. That's that bar underneath this. So that means I need to fill in those dots. My coefficient of x, remember that's a on our parabola. So that tells me the parabola goes up. So if this is my x-axis and it's got to pass through those 2 points, that means my parabola looks something like this one more time. Let's go back to this symbol. What is that symbol? That's less than. So less than or equal to. Well, here's the equal to part, but where's less than? Less than is below the x-axis. So where is below the x-axis? That's this part. And again, what's the domain? Those are the x values in between here. So my answer is bracket -1 to 5/2 bracket. All the values between -1 and +5/2, any of those x values, if you come back and plug it in here for x, you would get something less than or equal to 0. So greater than is above, less than is below. All right, number 3. So again, we're going to look at the corresponding equation. How do I solve that? It's not a trinomial, but I can factor it. I can take out a GCF. So they're both divisible by 2 and an x, and I think I'm going to take out a -2. So set those both equal to 0. Solve for x. Put them on a number line. Now we're going to look at what symbol did we have to begin with. Did it have an equal to part? Yes. So that means put the dots. If it doesn't have that bar right there, then you would put an open circle. What is a? What is my coefficient of x squared this time? It's -6, so that means that parabola goes down, remember? So again, it's got to go through my 2 points on my x-axis and go down. All right, so from here, that tells me the parabola goes down. These points is where the parabola goes through. Now, what part of the parabola do we want? Was that greater than or was it less than? Well, that looks like greater than to me. So greater than is above the x-axis. So what is the x values that correspond to that part? It goes from 0 to 7/3. That's your answer. So again, any of these values in here, you plug them in for x, do the arithmetic, you would get numbers greater than or equal to 0. Let's do again. So corresponding equation, I can factor that, set them equal to 0, solve, put them on a number line, remember in the right order, negative then positive, smaller than bigger. Look at this. So do I do open or closed? Closed. What's your coefficient? So that tells you it goes up. So I need a parabola that goes up. And then greater than or less than? Greater than, so that's above the x-axis. Keep in mind one more time that this number line I'm drawing, that's my x-axis. So above or below, greater than is above. So I want all of these values for x. What are those values? Go left to right. So I'm going from negative infinity to negative 2 bracket because of the equal to part, and then 5 to infinity. So that means any of these numbers in for x would give you something greater than or equal to 0. Now these are weird. If you notice, they're almost the same problem, but one's less than or equal to, one's greater than. Let's see what happens. So we're going to make it an equation. I can factor that. Ooh, but they're the same. So really, I only have one number that goes on my number line. Just one. Keep going. That has an equal to part, so I fill it in. A is 1, so that tells me the parabola goes up. Now, if it goes up and it only can go through the x-axis one spot, where's that one spot? Well, the only way that would work is if the vertex was that one dot. That's it. Any other way, if you were to draw it like this, it's going to cross it in more than one spot, so you can't do that. So only one spot. Now, do we need less than or greater than? That looks like less than. So that's below the x-axis. I see nothing below here. So there's nothing below, but what about the equal to part? Is it ever equal to 0? Yes. The only time it's equal to 0 is when x is equal to 1. There is no less than part because nothing goes below, meaning there are no numbers you could substitute in there to get something less than 0. So, if we do that same problem, same algebra, same number line, but this time we have an open circle, right? Because there's no equal to part. And we want greater than. So we know we want greater than, which is above. And we know that A is 1. So we have that same picture, but this time the parabola doesn't ever equal to 0 because you have this open dot. But that's okay. We want above, which is here and here. Well, what's that part? Doesn't that mean here and here? Isn't that the whole number line? Is it? Is it every number? No. It doesn't include 1. So it's from negative infinity to 1, and then 1 to infinity. It's everything that the other problem over here is not. Now those are weird. That's because these values were the same and you only get 1 point on your number line. A little tricky. So just going through the steps, you're going to have all problems that factor, so you don't have to worry about that quadratic formula. You remember the equation, you plot the numbers on the number line. Again, I did not use what's called these test points. A tutor, a different teacher might, and that's okay. I'm using the graph and the knowledge of my parabolas. Do they go up because A is positive, or do they go down because A is negative? And then I just look at the graph and write my answer.